Right. So you are welcome to the solution to problems. We gave a problem on this channel as test your knowledge, and then we want to now give solution to the problems. I know many of you have tried it. I'm talking about the problem that you see on your screen here that we call test your knowledge. Last time, you see the instrumentation lectures, test your knowledge based on thermocouples, and other devices, which include the Bernoulli's theorem on that question. Now, we want to give a solution to the problems in that video. I know most of you must have actually tried the problem. Now we want to give solution to the problem. Now, if you have not seen the questions, I'm going to leave a link in the description. You will see the link to the problem, the description of this video. Just follow the first link to show you the problems that we are talking about. And then you can actually have an idea of the problems that we are solving. Now, we want to look at the problems so that we can actually give a solution to the problems now. Now, the link to the problem is also shown on the file here. Let me show you my screen once again. You can see the link to this file. You can see. Okay, let me show you the screen, that file that gives you the link to the video. This is the link. You can see it on the screen. Now, you can check the description of this video also. You see the link to that video. That is a problem that we're about to solve. Now, looking at those problems, we want to look at the solution. Now, the first question there asks about the disadvantages of using thermocouple as a transducer. Three disadvantages can be mentioned. The first one is that thermocouples have a low accuracy, and hence they cannot be used for precision work. That's one disadvantage. Another one is that thermocouple metals can be affected by the operating environment. And then to prevent contamination of the device, we need to use precious metals such as platinum or its alloys. Platinum and its alloys can be used to build the device in order to be able to withstand the operating environment, contamination from the operating environment. And then, apart from that, the metal will be put in an open or closed end metal protecting tube or well, and that makes the construction to be more complex. Apart from that, the circuitry of thermocouple is complex, and since the device is placed remote from measuring instruments, measuring device, it makes it necessary to use wired extension to compensate for the measurements, and also compensating wires may be used, which may be of the same material as the thermocouple wires. So these are some of the disadvantages of using thermocouple as a transducer. Now that is the first question. The second question has to do with a calculation based on thermocouple as well. And looking at the screen here, this is a formula of interest in this problem. E equals alpha theta 1 minus theta 2 in brackets plus beta theta 1 squared minus theta 2 squared in brackets. Now, that is the formula of interest. Now, this formula, you need to put in the values given in the question. But before you do that, your best bet is to arrange the formula in a way that forms a quadratic equation. So we expand the equation here first, expand the equation out, then you get this second line. When you get this second line, then you can divide through by beta to simplify and make a theta 1 square the first on the list, and that is what we are looking for. That's what we are about to calculate. So when you do that, you achieve this. You achieve this line here by dividing through by beta. Now, having got that, you can substitute and place the values of the values given in the question into the equation, and that's what we are doing. The second line here, the second line. We can see the second line, the following line rather. We are putting the values of alpha and beta, and also theta 2 into the equation. So after then we can simplify the equation. So when you divide through, you get this long division that you simplify. Now, your best bet is to simplify that correctly and arrive at a quadratic equation in terms of theta 1. All right. So you could see that in this line here. You see theta 1 squared minus 4268.3 theta 1 minus 87229.3 equals to 0. That is the quadratic equation, the applicable quadratic equation in the solution. Now we solve this quadratic equation now in terms of theta 1 by using the quadratic formula. Quadratic formula that says x1 and x2 equals minus b plus or minus square root of b squared minus 4ac divided by 2a. So when you apply that, you get this equation here, and then you can simplify and get the value of theta 1. The applicable solution in that calculation is theta 1 equals 4288.64 degrees Celsius. And that's the solution to the problem given. All right. So that is it. Now, some students will go through this solution. We start the solution by writing the formula, and then on the second line, they either put the formula there or simplify a little bit, and third line put the parameters in the solution there. That is not the best way. Your best bet is to simplify the equation in this manner first, before you now put in the parameters given into the equation and simplify and get the quadratic equation of interest. So putting the values we know, make your calculation to be very, very complex, and with that, errors can easily come in. So the best way is to solve it in this manner, simplify, get the equation in this manner, put the values, and then simplify the values by dividing through and get a simplified quadratic equation that you can solve. So that is the best way to solve that problem. Then number 3 is about Bernoulli equation. Bernoulli equation here, we have the formula. This is the formula of interest. This is a pertinent formula in that solution. P1 over gamma plus Z1 plus V1 squared over 2G equals P2 over gamma plus Z2 plus V2 squared over 2G. Now, what we are looking for in this solution is V2 squared. And then we want to get the value of V2. So we can make V2 squared is subject of the formula like I did here. So this is an equation that we have collected like terms together, making V2 standing on left-hand side of the equation. That is V2 squared. Now, simplifying further, we got this. V2 squared equals 2G into the brackets, Z1 minus Z2 plus P1 minus P2 over gamma plus V1 squared. Then we can simplify further by making V2 the subject of formula and then get square root of the other side of the equation. Now with that, we can put in the parameters given in the equation as we have in this line. When you do that, then you can actually find the square root of the values gotten and get your answer as 11.23 meters per second. 11.23 meters per second. Once again, in this solution, we have a very long formula with so many parameters. The best way to solve that is to make the subject of formula of what we are looking for. What we are interested in is V2. So we make V2 the subject of formula in the unknown variables. Before, finally, we now put in the values, the parameters, in the values of the parameters given in the question. And then we get the answer out. The answer is 11.23 meters per second. So that is that. Now, the next one is number 4. Number 4 has to do with a capacitive transducer. This is a formula of interest. This is a pertinent formula that we can use to calculate the capacitance of a capacitive transducer as given of that simplified. As you see, the second line here, we make HL the subject of formula. And then we now put in the values, the parameters given in the question. The height of liquid in the tank is HL, that is on the left-hand side of the equation. And so other parameters, the capacitance, the C, the radius of the inner cylinder, the outer cylinder, they are all there. And then the height of vapor and the permittivity for the both vapor and then the liquid, they are supplied, and so they are substituted into this equation. And then when we come out with that, we arrive at a 249.65 calculation. 249.65 divided by 4.7. Now, when you simplify that, you get 53.12 meter. Now, in this problem, the best way is to actually make the unknown parameter the subject of the equation. So the best way is to make the unknown the subject of the equation before you put in the parameters supplied, then you simplify. And so when you do that, it makes the solution to be easier. And then we come out with the answer, 53.12 meter. So anything different from that is a wrong answer. So you can check that, confirm your own solution, but check if you have not been able to arrive at that answer. Okay, so that is it. So that is how it is. So subsequently, we are going to have other test your knowledge problems. We're going to have other test your knowledge problems subsequently, and then we provide solutions also to them afterwards. For now, I want you to go back and try the solutions yourself, comparing with the solution in this video. Don't forget, the problem being solved is in the, there's a link that leads to the video for the problem being solved in the description. So check the description. Down in the description, you see a link. And don't forget also, if you have not subscribed to the channel, we want you to subscribe to the channel, like the video, and also share it. We want you to share the video and like it as well. It's important. So thank you very much for watching this video. Hope to see you in the next video. Bye-bye.